Swayam Prabha. Digital India. Educated India.
Hello everyone, my name is Professor Gauravdhar Bhomik. I am from Agriculture and Food Engineering Department of IIT Kharagpur. So welcome to the last lecture of module 1, which is like conservation strategies that will be discussed from the module 1 of introduction of aquaculture for the course Advanced Aquaculture Technology. The contents that I will be covering the resource use efficiency, the impacts of aquaculture on biodiversity, land use, water use, the energy use, feed fish use, chemical use, and the water pollutions related to the aquaculture and its impact on the biodiversity, which is one of the major informations that we will be discussing in this particular module, in this particular lecture series. So what is the resource use efficiency? So in general, Food and Agriculture Organization, they estimates that almost 32% of the global end use energy consumption is to produce only the food for the human consumptions. So in general, it seems like we are using a lot of the energy, we are consuming a lot of energy for the transportation and all, but actually if you see the figure, almost 32% are actually involved with the world food production systems. Producing a food for the growing populations, like the now see from like we are going to like almost more than 7.5 billion people in this earth right now at this moment. So and it keeps on growing. So for this growing population for itself, producing food is a huge task, but we have to do it without further depleting or further utilizing any non-renewable energy sources, reducing the regeneration rate of renewable sources, and also we have to make sure that it will not cause any ecological disaster because of the farming practices or the food production systems that we are adhering to produce the amount of food for the population, for our human consumptions, which is actually a great challenge, which is one of the major reasons that we need to go ahead with the proper resource use efficiency, so that the resources or it can be energy resource, it can be the existing it can be the material resource. So whatever we are utilizing, it has to be at its best and it has to be at its optimal way. So the need of these movements are like improving the resource use efficiency definitely, and to reduce the environmental impact of this food production systems, of our food production units, depending like it can starts from the resource utilization or the fresh water utilization in the pond to the byproduct development, from the byproduct recovery from the processing units, of all the fish feed, all the say like normal food production units. So all these processing units, the final byproducts that we'll trying to procure, like somehow get out of it. So we have to go through a proper environmental study, we have to go through a proper economic and resource use study, so that whatever the amount of resource, whatever the amount of energy, whatever the amount of impact it has on the surrounding ecosystems can be reduced, and in a very impactful way. So in general, the aquaculture production, what we normally have, it comprises it can be of like major 4 components. It has it's not limited to it, but it has these 4 major components. First of all, the inland aquaculture of fish in pond, okay, Second is the inland and marine culture of fish in cages. Third is the crustacean culture in coastal ponds, and the fourth is marine culture of bivalve mollusks and the seaweeds, etc., etc. So these four are the major aquaculture production in the world, worldwide. So the impact of seaweed or the bivalve, it's not much in the environment point of view, and also the economic point of view as well, because they have very little, even like sometimes like there are very little negative impact, but mostly it is positive, I would say, because so because seaweeds and bivalve, they utilize a very low amount, we need a very low amount of input for them to grow in the system, in the farm. Additionally, what they do, they treat the water, because of their food habits. So they actually treat the water to get rid of some amount of pollutants from the system itself, and they utilize it, and so somehow they can actually helping the environment to be further pollutant free and all. Aquaculture in general, they utilize huge amount of fish meal and fish oil, which has a very huge negative impacts on the biodiversity. In coming slides, I will be discussing about this in details and also in number, that you may have this thinking like whatever the fish that we are using is the total amount of fish that actually utilizing, we are whatever the amount of fish, whatever the amount of aquaculture product we are producing is actually for the human consumption or the byproduct utilizations. It's actually not. A major portion of the fish we are actually cultivating all around the globe is actually used for cultivating the other type of fish, the higher hierarchical fish, or the fish which utilize those the carnivorous fish, which has a much higher economic return. So it has a very huge environmental impact of this kind of fish meal or the fish oil production, which is used for the consumption of further aquaculture benefits and all. So in general, the impact of, I will discuss about those fish meal in details in later slides. So in general, the impact of aquaculture on biodiversity, if I discuss, so it has the impact on the land use, the water uses, the energy uses, the fish feed use, the chemical use, and the water pollutions. So I will be discussing all these 6 points in details in the later slides. And though there are when we cannot talk about the negative impacts only, there are a lot of positive impacts also associated with it, because the aquaculture is a major source of seafood, and it's a major source of the most dependable source of animal protein that we can have to nurture and properly balance our diet. It provides the employment to the hundreds of millions of people all around the world. The international trade of these aquatic products contributes to the global economy at a very high range. So even the island based countries, for them this aquatic product trade is one of the major source of income, and it actually gives them the major boost in their economic system, in their country based economy or their GDP system. So there are a lot of benefits of aquaculture as well, which are the major reasons of we want to go for it. So whatever the negative impacts that it incurs, so we have to try to find out the way to somehow minimize it or try to neutralize it if possible, or completely nullify it, this kind of negative impacts. So in order to do that, we need to understand what are the negative impacts on this on these aquaculture processes, on this land, water, energy, the water, etc., etc. So in order to understand this, let's go ahead and find out and enhance our idea about the negative impacts of aquaculture in general. So when we talk about the land use, so in general the land use for a farm, if I ask you the land use for a farm, suppose you have a 10 feet by 10 feet of a small aquatic pond you are developing in the backside of your farm, in your house here, or backyard. So you'll say, what is the total amount of farm that it requires? You'll say yeah, it's only 100 square feet because it's 10 feet by 10 feet, that's it. But it actually not. Okay. So why it's not? The actual land uses that you are actually incorporating here when we go for life cycle analysis of your product, you need to incorporate the supporting support area needed for producing the feed as well, because your feed is not coming out of nowhere, right? It has to have support some amount of land it requires to produce the feed. So you may think about, oh, it's hypothetical, how you can calculate that support area. You don't have to calculate that support area. There are standard practices in the, if you go for research, different research papers, there are standard practices how we can calculate that standard support area for a particular amount of surface area for your pond. Okay, so you can go ahead with it. This is the recent days practice. Earlier we don't do that, this kind of practices, but recently we started incorporating this kind of practices also. So to identify the quantify the actual impact on the land or the water for this kind of aquaculture practices that we normally do. The factor of 1.5 times the production of water surface area is about the average of aquaculture land use in case of farm level. So, see, aquaculture farm level, when we go for the actual production surface area, it's like the 1.5 times the production surface area of normally we calculate, okay, when we talk about any aquaculture farm and all. The land area of aquaculture is around 0.66% of total agricultural area and 0.25% of the world land area. Can you imagine the amount of land that we are utilizing for just culturing the aquaculture system? So, what was it before? It was before maybe some mangrove area, maybe some forest. So what we are doing, we are going for the deforestation procedures, we are going for the mangrove uprootation thingy. All this, the procedures, all this, the things that we are doing to just to have a larger amount of aquaculture space, it has huge amount of environmental impact. Okay, so I'll discuss about it in detail. So aquaculture is considered as the minor contributor to the overall land use, but it affects significantly in the local level. See what I mentioned, like conversion of the mangrove areas to ponds, it's a major issue. Why we go for these things? In general, suppose most of the sea-based products that we are, sea-based culture species that we try to farm in our aquaculture farm, try to culture in our aquaculture farm, it needs the sea water, it needs a saline water. Okay, so how do we do that? We go for design the tight fed farms. Say suppose we need to design a tight fed farm, and we go for a proper discussion about its engineering details and all, and for that we need to say like couple of hectares of land by the side of seashore. That's it. We go to the policy makers, we ask them like we need these things, and they say like okay, let's go for it. Let's go have a land of this much area, so that will increase our economics. But before doing that, for the engineers and also for the policy makers, we have to think how much of an environmental impact it will happen. It will cause when you go for developing these huge land-based, this aquaculture system, the aquaculture pond and all, which is just by the side of the seashore, because it's a rich source of biodiversity. It's a rich source of mangroves are there. So those mangroves, you have to get rid of all those mangroves or you have to cut a canal through this mangroves, so to get the seawater when there is a high tide, and so that all this construction actually causes a huge harm to the aquatic system, to the surrounding ecosystems, and it is not in a very small amount, it's actually huge amount of harm it can cause. And earlier we don't worry about it, say like 30-40 years back, 100 years back, but now we need to really think about it. Do we need this kind of systems? And if we need, how we can make it scientifically benign, more scientifically accurate and optimum, so that we do not harm the surrounding ecosystem, at the same time we somehow try to contribute to the ecosystem. Okay, so that's how our approach should be. The intensification of the aquaculture, it decreases the amount of land needed per ton of production at the farm level, which is somehow good, because utilize the land that you are using in a maximum way, in an optimum way. And how to do that? You intensify the aquaculture product. If you intensify the aquaculture products, go for the intensive aquaculture, maybe it comes with some other engineering developments, go for it. The science is already developed, there are ample amount of research has already been done. People are started thinking about producing aquaculture in like outside this globe. So if why don't that means there are technologies available, and it is actually available. Just go for it, search for the research papers, come to the researchers like us, and we will give you the idea, we will give you the proper scientific methods that we need to inculcate to utilize it to your farm to produce maximum in a least environmental with the least environmental effect, or like least destruction in the environment or the ecosystem. So in order to intensify the aquaculture, we need the advanced engineering systems, but this more we can say that decreases the amount of land, but actually more land is needed for producing the ingredients of the aquaculture feed. We don't think about it. So the moment I told you that the intensification of aquaculture will reduce the land like anything, but actually if you see if you do the proper life cycle analysis, it's not. The actual amount of land that is needed now for the intensive aquaculture is less, but the food or the feed that is required for that aquaculture species to sustain is more, right? So in order to do that, because it is not at all surviving through the natural feed anymore, so it has to be, it is a I told you, like it's a simple food chain. You supply the proper aquaculture feed, you will have a good amount of yield for your culture species. So where to get those aquaculture feed from? It is developing somewhere. It is getting this aquaculture feed can be of some other type of fish as well. So in order to develop that fish, you need to have some amount of land. So actually you have to do this very fine calculations, like whether the intensification is actually reducing the land required land or not, or where actually it's just a fake term. So these are some stuff we need to remember, we need to understand when we go for the actual design of aquaculture farm. So that's what we want for all of you, like whether you are from fisheries biology, fisheries bachelor, or fisheries engineering, or aquaculture engineering, or an aquaculture enthusiastic. You have to know these matters, you have to know these facts, so that when you will be discussing, when you will be designing your own aquaculture farm, or you will be you'll be consulting an aquaculture farm for your customer, for your buyers, you will give them the best possible outcome with the environmental benign way. Okay. So water uses, when we talk about the water uses, it can be the green water, the rainwater that evaporates during the uses, the blue water, the surface water or the groundwater that evaporate during the uses, and the grey water. It's the amount of water needed to treat the waste resulting from the water uses, or the fresh water exchange that we need to do during the water uses. So all these type of water uses are the one which are in the negative side, which we have to get rid of. We have to these are the the outcome of the aquaculture farm that we normally have. So in general, the consumptive water use in freshwater aquaculture pond averages out of about around say like 12,700 meter cube per hectare, according to the literatures given by Boyd and McNavin in 2015. So using a global yield of say like pond aquaculture of around say like 2,496 kg per hectare, so total water use would be around 5,088 meter cube per ton. Can you imagine the amount of water that we are utilizing? 1 meter cube is 1,000 liter. Now just imagine the amount of zero that you have to, the another 3 zero that you need to put in this number to just to convert it to the liter, so that it will be much easier for us to understand. So this much liter of water is needed just to produce 1 ton of product. So we need to minimize these uses, we need to optimize these water uses for better future. The direct water use in a freshwater aquaculture, pond aquaculture would be around approximately 111 cubic kilometer per year. So in general, cage culture and raceways, they use less amount of water, they are in-stream water users they use. So they are not even something around 0.25 cubic kilometer per year, and that's mainly contained in the harvested biomass, that too. So we can go ahead with this kind of culture processes, so that we can we can minimize the water uses and at its maximum. Consumptive water uses for making the feed ingredients is approximately around 275 meter cube per ton. So for around say like 41 million tons of feed that is consumed in 2014, this data is given. 275 meter cube, 275 multiplied by 1000 liter per ton of production, that is the amount of water that it's needed for producing the feed ingredients all over the world. It is huge. The water use for feeds is approximately 1 cubic kilometer per year, and it's the primary water consuming activity in the cage and raceway aquaculture. So, in case of raceway cageway aquaculture, in stream water uses, we can be proud about it. We are not utilizing much of a water, but what about the feed water? What about the water that is needed for producing the feed and all? Okay, so that also has a huge impact on the system. Okay. So, what are the ways to reduce this water use? The first of all, the production intensification. So, it can be done by by like increasing the production. Go for the intensive aquaculture systems. We can increase the production assuming no change in the food conversion ratio, which reduces the water use. Water reuse, that's an important thing. We need to harvest without complete draining. Just wait for proper harvesting process to finish. Reuse the water for culture after treatment. Go for the recirculated aquaculture system, biofloc technology. There are a lot of technologies nowadays available to treat the wastewater coming out of the aquaculture pond, to treat the water and reuse it back to your system. Construction technique to minimize the seepage loss by proper site setting and the construction practices. Water level control to capture as much as water as possible. So, you can develop your farm in such a way so that all its rooftops and all its available spaces, land spaces are being utilized to capture the rainfall at its maximum. And if you can utilize that rainfall, that water uses will be minimized like anything. Okay. So, in general, in order to capture the rainfall, you have to have at least maintain 10 to 15 centimeter gap in the water level below the outflow level, so that that rainfall water can be captured and can be utilized in your pond. There are other ways. You have to, in general, water exchange is a bad practice. You just don't go for water exchange, rather you go for the treatment of water and all. Okay. So, because it does not improve the water quality, but it increases the water uses and the pollution occurs in general. Because what we do, water exchange means whatever the used water, we just throw it away in the surface water bodies and we use the fresh water to use it back into a system. Then there comes the mechanical aeration, which is more effective than the water exchange because it can maintain the adequate amount of DO concentration. But another important thing, everything comes with the pros and cons. You have to optimize the system, because the mechanical aeration, it will help you to get more amount of dissolved oxygen. Okay, but because of the mechanical aeration, more amount of water is getting splashed out in the system, in the environment, in the air. What will happen because of that? The evaporation loss will be maximized. The evaporation can be happen because the evaporation, it needs more amount of surface area for water to get the vaporized into the air. So, evaporate into the air. So, if it gets more amount of surface area, the more amount of water surface is now available for evaporation. So, because of that, the evaporation losses can be very high. So, but it is not as much as the losses that incurs due to the water exchange. So, that is why we still go ahead with the mechanical aeration. But if we can do, if people still doing it all over the world, the scientists are doing it, they are trying to find out more optimal way to increase the aeration, but not doing it mechanically, not doing it by splashing the water, so that it will increase the evaporation losses and all. What they started doing, they started designing different kind of aerators which will reduce the water losses due to the evaporation as well. They go for the submersible one, they go for some other flappirators and all, the very advanced stage aerator systems and all, where they can get rid of all the evaporation loss that incurs due to the mechanical aeration systems and all. So, total energy use is, according to the Food and Agriculture Organization 2011, the estimated energy use for capture fishery is around 2 exajoule per year. What is exajoule? It is 10 to the power 18. We know like 10 to the power 6 is mega, 10 to the power 9 is giga, like that 10 to the power 18 we call it exajoule. So, 2 into 10 to the power 18 joule per year of energy is being utilized when we go for the capture fisheries. Let us talk about the aquaculture. What will happen in case of aquaculture? Several direct use of energy is there in aquaculture. facility construction, pumping of water, aeration, farm operations like in the electricity that we use in the farm and all. Other than that, what are the indirect uses of energy? The feed manufacturing. I always tell this is called the embodied energy. Embodied energy, you have to understand. The feed manufacturing also comes with the cost of energy. Some energy is utilized in case of manufacturing of the feed as well, which you are utilizing. So, the cost when you calculate, it is not the only cost of feed. The energy losses incurred because of the production of the feed has also to be incorporated when you will be designing, when you will be doing the proper life cycle analysis of your system. The distribution to the farm. So, all these things are actually incorporated within, we call it embodied energy. So, this embodied energy, it contained in aquaculture feed ranges from 4 to 10 gigajoule per ton. What do I mean by gigajoule? 10 to the power 9. So, 4 to 10 into 10 to the power 9 joule per ton of production is the energy content of the aquaculture feed, and which is really huge, but we do not talk about it. We need to start thinking about it, how it involves in aquaculture production and what are the possible consequences. The aeration is also a major energy input to the aquaculture. For example, at an aeration rate of 1.5 kilowatt, 1.5 into 10 to the power 3 watt per ton of production, and also say like 1000 hour of product aeration during a particular crop or particular season. So, the consumption of electricity would be approximately 5.4 into 10 to the power 9 joule per ton, or 4.4 gigajoule per ton of production. The facility construction can be amortized over several years and will seldom be greater than 2 gigajoule per ton of production. The energy to pump water for filling pond, replacing the evaporation loss or the seepage loss will not exceed more than 0.5 gigajoule per ton of production. So, energy conservation is important, but because most energy used in the aquaculture is coming from the non-renewable sources. So, what we can do? We have provision, we know how solar energy works, we know how wind energy works, we know how geothermal energy works. Just start utilizing those things. So, we can reduce the total energy required for the for this kind of for the farming, for your aquaculture farm. The combustion of the fossil fuels, it also the major source of the greenhouse gases, so which can contribute to the global climate change. So, that is the reason why I told you to go ahead, we design nowadays with our aquaculture farm with maximum non-renewable sources as possible, solar energy, wind energy, geothermal energy I told you, because in the temperate region. So, you know, for us it is very easy. In India we can go ahead with the development of farming is very easy, but suppose in the temperate region, what they will do in the Europe or in like northern part of America, Canada, what they will do, how they do the aquaculture, where their annual average temperature is very high, very low. How they will do the production, how they can keep warm their farm, how they can keep warm their greenhouse, so that where they are producing the farm, producing the this aquaculture farm, they are using the geothermal energy. We can also utilize the geothermal energy properly for reducing a different kind of cost involved for the farm production and all, to reduce the air conditioning charges, to reduce the different to maintain the proper temperature inside your system, to have a maximum benefit out of it. So, we need to think about all these renewable sources of energy, and which can be utilized to further reduce the energy requirement from the aquaculture farms. The fish feed uses, the large amount of fish meal or the fish oil is used in the aquaculture feeds, especially for the marine streams and the carnivorous fish such as trout or salmon. So, at present 60% of the global supply of fish meal and the 80% of the fish oil are actually included in the aquaculture feed itself. Can you imagine the total amount of, it's almost 60% of the global supply is only utilized by the fish itself. So, it's like, you know, lower trophic culture is actually utilized by the higher trophic culture, and this loss we have to incorporate when this considerations we have to incorporate, and each and every design criteria, that how this fish meal, how this lower chain, like lower trophic species are involved in culturing the higher trophic species, and how they are interrelated, what are the design criteria, what are the numbers that you have to incorporate when you will be designing a farm. It is very important. That is the advanced stage of aquaculture practices that we are doing right now all over the world. The fish oil or the fish meal, they are made from the pelagic fish, trash fish or the bycatches. This capture of this pelagic fish are the normally this column dwellers, like normally they are not the benthic zone, they not dwell on the benthic or they not the surface, they normally stay in the pelagic zone, mostly in the middle portion of the, like they call it the column dwellers, what is column dwellers, we have already discussed. And this bycatch are the one which somehow you go for, say, catching salmon and you started somehow by mistake, not by mistake but because of the net and all, you started capturing the other sea mammals and all. So this is called the bycatch, which you are not targeting. This is a non-targeted species that by mistake not by mistake, it because of that is also its normal dwelling zone, so it can also get caught. So what you want to do, what you going to do with that? So most of the cases they try to get it back to the ocean body, but 60% of the cases they cannot survive, because once this bycatching thing happened, they somehow get injured severely, and they are out of the water for several moment of time. They cannot sustain. Most of the cases these bycatches cannot sustain, and these bycatches end up losing their life. That's a major and horrible mistake, horrible side effect, disadvantages of the capture fisheries. So it also affect, so the capture of these pelagic fishes and bycatches, as I already discussed, it affect the biodiversity in the ocean. And the most negative impact of aquaculture imposes in the environment is this fish feed use. Each kilogram of farmed fish consumes more than 1 kilogram of fed fish in the form of fish meal or fish oil. Sounds funny, but it is true. So each kilogram of fish that we are consuming, we are farming, it's actually can consume more than a kilogram of fish feed or as a fish meal and all. So fish feed use, the amount of feed fish that we needed to grow 1 kilogram of fish, we call it fish in fish out, Fifo. So don't confuse with FIFA. So it's Fifo. So it's calculated from the FCR or the food to food conversion ratio, the percentage of the fish meal or fish oil in the feed, and the ratio of the quantity of the feed fish that is required to produce a unit of fish meal or fish oil. It's called the Fifo. So fishes required high diet, diet which is high in fish meal, they have a Fifo of more than 1, and the fishes which requires less amount of fish meal, like mostly the herbivorous fishes and all, so they have a Fifo of very less than 1. What is the viable solutions? Favoring the farming of low trophic level fishes. As I told you, go for the herbivorous fishes. Okay, they like the carps and the catfishes, even they can grow on feed without or even a very little amount of fish meal and fish oil. So go for culturing those fishes, which will supply the amount of protein required for the human consumptions, and also it will reduce the environmental impact, and it will reduce the water consumption at a very high rate. Chemical uses, the liming material. We use a different type of limestone for which has the adverse effect on the environment, but we use it for liming purposes. We use it for preparation of our pond and preparation of our tanks and all. And the reaction of this limestone has it contributes to the acidity, which which contributes to the global carbon emissions and all. I'll discuss about the number in details. This fertilizer manufacturing is actually energy intensive. Almost 57.47 gigajoule of energy is required for the production of 1 ton of nitrogen, and 7.03 gigajoule of energy is required for per ton of phosphorus that is required in case of in the fertilizers. What will be the alternate? We can go ahead with the organic manure from the agriculture wastes. Use it as that's a very best substitute for the production of your systems. Antibiotics used in the aquaculture. Antibiotic use is the last resort. The banned antibiotics should not be applied. Antibiotic treatment should follow the recommendations on the product level. Then only you go ahead with the antibiotics. Just don't use it antibiotics, no matter how bad it is. Like either you use it, put the fishes in the quarantine tank and then use it a little bit, but try to use it as minimum as possible. Chemicals, if all these kinds have the very which has the cautions, to try to avoid them for its harmful effect on the environment and also in the system. So when we talk about the water pollutions, so we talk about the pollution caused by the nitrogen, pollution caused by the carbon, etc. Right? So major pollution caused by the nitrogen species and the carbon species. In general, the system load of any components like nitrogen, it can calculate say like kg, like with this equation system load in for a particular element I. So, in kg per T is equal to the Fi into FCR. Fi is the what? Is the decimal fraction of that particular element in the feed multiplied by the food conversion ratio minus the Bi, which is the decimal fraction of the element in the harvested biomass, multiplied by the 1000 just to convert it to ton to kg, kg to ton or ton to ton to kg. So, what does that mean? So, Fi is the amount of decimal fraction of the element, say like nitrogen percentage present in the feed, multiplied by the food conversion ratio. That means, food conversion ratio is what? The amount of feed that is actually being utilized, converted to the biomass of that particular fish. So, if you multiply this number, you will get in the biomass, in the further the final product, what is the percentage of element that is available, minus that is the ratio that you can get from the beginning, and minus if you do this final harvested biomass, if you do the calculation of the decimal fraction. So, this difference will give you the amount of element that is lost because of the water pollution, right. Feed decimal fraction of the element in the feed multiplied by the feed conversion ratio minus that should be the total amount of feed element available in the feed, but actually when we harvest the biomass, if you calculate the total decimal fraction, that will definitely be less than the actual Fi, that you definitely it will be less than the decimal fraction of the element in feed. This ratio, this value multiplied by 1000 will give you the system load or the actual loss of pollutant like the nitrogen, say like pollutant in this particular case nitrogen, through the wastewater. The same way we can this will definitely cause the acidification. How we can find out the acidification caused by the feed? Kg of calcium carbonate per ton of production, NF into FCR. NF is the total amount of decimal fraction of nitrogen in the feed multiplied by the food conversion ratio minus the amount of fraction of nitrogen in harvested biomass multiplied by 7.14, which is like the calcium carbonate equivalent of acidity from nitrification of 1 kg of ammonia of ammoniacal nitrogen, and 1000 is for the kg to ton conversion. So, from this calculation we can easily find out the acidification potential production. Okay. The final pollution criteria that we can go ahead with the calculation of BOD, biochemical oxygen demand. It is the it means the amount of oxygen required for the conversion of a particular biomass to a particular biomass or particular product to its end form. So, like I mean like amount of oxygen required for say like in this particular case, what is the feed BOD? That is the kg of oxygen per ton of production is equal to 1000 into Cf into FCR. Cf is the decimal fraction of carbon in feed multiplied by the FCR food conversion ratio minus decimal of carbon in biomass multiplied by 2.67 plus the same way for the nitrogen 4.57. What is this number 4.57 and 2.67? It is the amount of oxygen required for complete reduction of that nitrogen species is the number that it is standard, it is a standard, it's you can find it in the research articles, different research articles. From this equation we can get the feed BOD. So, how to reduce the water pollution, I will discuss in details in the later lectures, how we can, what are the procedures, what are the treatment systems that we have to reduce the water pollutions. First of all, good feed arrangement, feed management. You have to incorporate high quality feed containing no more nitrogen and like not more amount of nitrogen and phosphorus than it's required. The feeding conservatively, try to not go for overfeeding or try to reduce the quantity of uneaten feed. Go for plenty of mechanical aeration, go for proper waste treatment procedures and wastewater treatment procedures and all. So, these are the references that I have used for this lecture material, and thank you so much. So, this is the end of this particular lecture module. So, we will discuss more in details about the advanced aquaculture technologies in the coming modules. Thank you so much.